No, it won't be that bad. So this is your very basic level of chemistry. So today we're going to start our 9th investigation. We're almost at the end of chemical interaction. So our 9th investigation is called reaction. And we need to start by reviewing substances. Matthew, you can close that up. We're going to review substances, which we talked about. Was that our first? Yeah, that was the very first investigation. Okay? So you tell me if this is true or false. Every substance is a unique form of matter and has unique properties. Raise your hand if you say true. Should be raising your hand. That is a true thing about a substance. Okay? Substances are composed of elements. Raise your hand if you think that is true. That's also true. Substances are defined by the kinds and numbers of elements from which they are composed. Substances are defined by the kinds of and numbers of elements from which they are composed. That is true. Where would you see a big list of those types of elements? Yeah. Periodic table of elements. We're going to go back and review that in a second. Substances can be composed. You must have really liked that, huh? Substances can be composed of one element or two or more elements bonded together. Is that true? Yes? I agree. Can you give me an example?
Let's take water.
Yeah, what is water?
Just some hydrogen and some oxygen.
Good. Substances can be represented by a chemical formula. Who says true? Ooh, you should. Remember when we did all those different white substances, we came up with chemical formulas of all of them? Like CO3, blah, 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 blah. Had a bunch of different kinds that we looked at. Okay? So those are substances. Now we're going to get into something even more intricate than a substance. And that's the atom. Okay? So an atom is a smaller piece that makes up a substance. We're going to use little circles to represent atoms. Okay? I've got these magnetic circles. So this would be an oxygen. That might be chlorine, hydrogen, and so on. Okay, so I've got a couple of those different atoms. All substances are made up of elements. How many different elements were there? Do you remember? Yeah.
Isn't it 118?
Let's take a look. See if you're right. I've got the interactive periodic table of elements here. I put it up at the top. Remember, these are all those different elements. We got down to 100 and... Oh, you're right, 118. Now this one's kind of nice because you click on it. And you can see all the different information about it. We're going to start digging into this a little bit more because you see all these other little dots and circles, and we didn't really talk about what any of that means. But hopefully we'll get into that so you can understand why do I have all these little circles, because that looks a little different than xenon, which looks like that. Looks a little different than argon or chlorine. Let's go to hydrogen. We use that one a lot. Oh, hydrogen. That's pretty simple. Where's oxygen? Because we know that's what oxygen looks like. Okay. So we'll take a look at all of these, and today, and we don't have much time left, but as we get into this tomorrow as well, we're going to be using these little magnetic atoms to represent different atoms coming together. Particles of elements combine to make all substances. And so the basic particles of elements are called atoms. Let me say that again. The basic particles of elements, and here's our 118 different types of elements, the basic particles are called atoms. Okay? So our driving question is going to be this. How do atoms combine to make new substances? Okay, and we know that atoms are the basic particles that make up all of these elements. Okay, so let's take a look at this. Let's go... That's too many of them. Let's say I've got oxygen and oxygen. Okay, that's a new particle. How many atoms have combined here? And how many kinds of atoms have combined? If I got oxygen and oxygen. This is not a trick question, you just need to be able to count to 2.
This is a hard question.
How many atoms have combined? Everybody show me.
2.
2.
Peace.
How many different kinds of atoms? Just one, right? Because they're the same. I've got oxygen and I've got oxygen linked together. Okay? So, 2 different atoms, and yet they could be the same kind. When I have 2 or more atoms of the same kind, the substance is an element. So would this be an example of an element? Yes or no? Let me say that again. When 2 or more atoms of the same kind are combined, then the substance is an element. Is this an element?
Yes.
Oxygen and oxygen combined, that's 2 or more of the same kind. This would be the element oxygen. Now, let me add this. Another oxygen atom.
That's crazy, man. That's crazy.
Now, how many atoms are there? Not just one. Not just 2, everybody, but 4. 1, 2, that's 3. That's 3.
Oh, whoa, that's even better.
So 3, but how many different kinds?
1.
Still just one kind. So is this still an element?
Yes.
Yes, that would be the element oxygen. Are we okay with that? So the most basic particles of an element are atoms. Yeah.
We switched one oxygen out for a hydrogen. Would it be water?
Let's talk. We'll get back to that in a second. Let's talk about this. I'm going to take away 2 of these.
Oh, no.
Okay.
Whoa.
This is a particle of the substance called ozone. It is made of, well, actually, I'm sorry, what I had up there before, the 3 oxygens, that was part of ozone. But now I've got 2 hydrogens up here. And I've got an oxygen in there. What is that? Water. Is water an element?
Yes. And no.
If water,
It's a substance.
if
No.
water is an element, please show me where I have water. Is that what's the
False.
what's the
It is
symbol? Is that
not
like
an element.
WA?
Water is a substance that is made out of elements.
Okay, so make sure we're
True.
using the right terms. You said that well. Water is not an element. Water is a
Substance.
because what did we say a substance was?
2 or more elements. If 2 or more elements combine.
Correct. And so this is no longer an element. Remember we said elements were 2 or more atoms that were the same. This is no longer the same because I've got 2 hydrogen and oxygen. Okay, so now this is a substance made up of elements. Yeah.
Is fire an element? Like on the table?
Fire is not an element, no.
Then what is it?
It's a deep question.
Lincoln
The
Steel.
study of fire. That would be kind of fun to do. Maybe we should add that in.
I feel like you said
Okay. What's another name for water? H2O. When you've heard of water listed as H2O, did you know that the 2 was a small 2?
yes.
Like this?
I did.
Okay.
Yeah.
What you learned as H2O was probably just you heard that. Oh, that's another way to say water. What you were actually learning was the chemical formula. Okay, so H2O is a chemical formula. It's showing you what every little particle of water is made of. 2 hydrogen atoms and 1 oxygen atom bonded together. Okay, so if I could split up water into tiny little pieces, this would be the smallest piece. And then if I was to take that piece and split it apart, it's no longer water, but it would be separate hydrogen and separate oxygen. Question?
What about H3O?
What about H3O?
What is that?
Here it is.
Oh my gosh.
Oh.
What a discovery.
What is H3O? Anybody know? No, I'm asking you. I don't know.
It's H squared. It's
I don't know if
H
H,
cubed.
I'm not sure if H3O is anything. It might be.
Should make it.
It's H cubed. H cubed O.
Should make it a thing.
H cubed O.
Now, going back to the periodic table. How many of these elements are compounds? And a compound is any particle made of two or more different kinds of atoms. A particle made of two or more different kinds of atoms. How many of these are compounds? Josie, why do you say none?
So sort of small, so it can be in one sort of.
Correct. Every element is made of one type of atom only, right? Isn't that what we said before when we had only oxygen up here? We said, okay, then it's, if I have like 3 oxygen atoms, that's still oxygen. If I group it with something else, now it's no longer an element, but it is a solution, it's a compound. Okay? How many of the substances we use in the mystery mixture activity, that was all the way at the beginning of the year, right? How many of those are compounds? Remember all those? I mean, we still used a lot of them throughout other experiments too. And yeah, how many of those were compounds? Remember, a compound is a particle made of 2 or more different kinds of atoms. Do you remember seeing the chemical formulas for those? Like H2O? Didn't we have those all listed out for road salt and table salt and citric acid and all of those? Did any of them have just one thing listed? Like the chemical formula for this is C. No! All of them had a whole bunch of different letters and numbers put together. What does that tell you about all of them? Oh yeah.
They're compounds?
All of them were compounds, right? So all of these are not compounds because they are single elements. All of those solutions that we used were all compounds. Okay? I want to show you one other thing for today. Do I have it up here still? I do. I'm going to pass this out to you though as well. It's a sheet called Atoms and Compounds. You guys can partner up. Cece, you can come partner up with Enya in just a second. Marie and Matthew, you guys can work together. You guys can work together. You 3 can work together.
Yeah.
You guys can be partners. You 2 can be partners. Stefan, Corey, you guys can be partners. Okay, so here's what I'd like you to do. Take a look at that sheet. Look over the diagram, discuss what you think it represents. Okay, take your time. You guys each have this in front of you. I'll keep it on the board as well. But what does this sheet, what's it trying to explain to you? You've got 1 minute. Ready, set, go.
Correct.
What does it mean? What does it mean?
What did we do? 4 hydrogen, 2
Explain
oxygen. Is that still water?
make different elements.
It's not?
And how
Why not?
different kinds of compounds
Like
and
this.
different elements.
No, but
That is correct. What is CL?
But I guess you wouldn't think that two
What is
oxygens
CL?
would equal
CL is chlorine.
That was something.
we did 2 oxygens and 4 hydrogen.
What is
That's
NA?
still water.
Na is, I believe it's sodium.
Yeah, I know, but we said like adding.
NA?
Yeah, that is
Oh.
Na.
We'll just list
Sodium.
all we do.
But S is sodium. What is that? What? S is sulfur. So N is sodium chloride.
Yep.
If we made 4
What
hydrogens
is
and 2
AR?
oxygens go together, would that still be water?
It's argon.
4 hydrogens and 2 oxygens go together.
Maybe it would just be, would it just be
There,
water?
once you get into chemistry, you can actually, you'll find that you take stuff like this.
Yeah, it's just
And
sodium
kind of
is
like
a chemical element with a symbol Na and the atomic number.
It would just be more water.
Alright, next
Well, then
question
we
we have.
could do
Okay,
3 hydrogens.
we are out of time. Here's what I'd like you to do. For those of you that have that sheet of paper that looks like this, hold on to it. This is the first thing that we're going to do when we start tomorrow. We're going to go through this and see if what you thought this represented is truly what it does.
Don't have spins tomorrow.
Oh yeah. I suppose we'll get back to it on Friday then.